Hi, I'm back again. And I'm going to talk about something that I don't really remember the answers to, but it was something kind of similar to this. I think there were five multiple choice, and there were three correct answers as to what I determined. So they went something like this: A and B are non-negative. A plus B is less than or equal to 2. And then a combination of these where they were anded together with the word and then these were I guess just incorrect answers that were not right. So basically I kind of figured out the system that was going on here, and I had an inkling to what was going on, and I had a feeling that, well, I kind of knew that they only allowed one multiple choice answer to be correct, so I determined that it would have to be E, because E was kind of more restrictive, and it was made up of these two correct answers. But then I kind of thought that, well, actually then technically you couldn't say that C was incorrect, because if you just look at it as a statement, then you evaluate it and it's actually true. So C would actually have to be a true statement as well if E was true, and therefore C should be correct. And same with B. B would actually have to be a correct answer then as well. And I kind of brought this up to my TA and I said, something's wrong here. These should all three be correct, actually, not just this last one. I'm pretty sure they just have the last one, but that's kind of dumb, And he actually kind of agreed with the answers at first, because he said that, well, this last one is kind of rigorous, which I actually looked up the word rigorous to find out exactly what it meant, because I actually thought that it would be rigorous to have these three set as correct and these two set as incorrect, and that if these two were set as incorrect, then it would not be rigorous, because less of the answers would have the correct truth value associated with them. So but I guess rigorous also means something about complete. So if we were going to be complete, would we want to be complete in having our set of correct answers, or would we want to be complete in stating all the truth to our answer? Well, let's just simplify the problem a little bit. So if I were to ask you, looking at this picture, there's a sun and there's a tree here, and I asked you, A, there is a sun, would you say that that's a correct or incorrect statement? Well, I guess I would say it's correct. There is a tree. Okay, that is also correct. And then C, A and B are correct. Well, that's just another way of writing there is a sun and there is a tree, right? So, but I just said A and B are correct, which kind of means the same thing, except now I'm referencing the actual answers. Now if I said that A and B are correct, but then I said that, well, I guess C is the correct answer because it's the most correct, and therefore A and B are incorrect because they're not rigorous, wouldn't I be contradicting myself? Because then I'd be saying both A and B are correct here, and then I'd be implying that A and B actually are incorrect. So the funny thing is, there was no kind of instructions with these questions saying, oh, select the one that is most restrictive, or something like that. And then I would be fine. Oh, okay, yeah, this is the most restrictive, obviously. But no, they didn't say anything about that. They just said select which ones are correct. And so I would say that B, C, and E are correct. Okay, well, I guess that's enough arguing for now. And now for some meta arguing. Why did I care about this so much? And my TA kind of gave up after a while and said, okay, you win the argument. Of course, I still went with the E because I just wanted to get my points for the day, but why did I care so much? Why was it so important to me? That's another thing I want to mention, because I am taking the time to make a video about something that seems so simple and so trivial, and many people might be wondering, well, what's the point? Why would it matter? You're just kind of making a big deal about something. Well, there is the idea that maybe I can convince 1 million people to not have this problem again, and therefore I save 1 million minutes and potentially hundreds of thousands of hours of people's time. Or maybe it's simpler than that. I'm getting at something that will matter more the more it's built on. For example, when constructing a program in software, if you make a very simple mistake at a low level and your program just kind of uses that code, it's not that big of a deal. You can just kind of correct it later and it didn't waste you that much time. But if you build on it and these potential errors are kind of inherent, then it takes longer and is more difficult to find these errors and to change your program around. Even if you're able to correct all the errors in your program after a certain amount of time, as soon as you change things around, you're going to have to do that all over again. And that's why we should, not just for software development, but also for mathematics, because of the Curry-Howard isomorphism, we should have formal ways to communicate things. We should have formal systems, and we should be able to expect and know what somebody is asking when they make a statement. When I took my computer science classes, especially for algorithms, there was not ambiguity in the questions. And even if there was and the teacher kind of made a mistake, all we had to do as students was just mention it in an email or something, or on an online tool that we were using, and the teacher would definitely fix it, because they were on top of their game. They understood their logic, they understood the importance of it, and that the questions we were being asked had to be extremely clear-cut and well-defined. And we had to know exactly what was to be expected and to be expected of us, so that we could answer these problems and make our learning experience work well. So yeah, there's just some critiquing here, but it's an important kind of thing to realize that it is good to view these things as formal logics. And I want to just kind of point out a reason why, for the opposite argument of why my TA might have thought that it was better to kind of select E than B or C, and that is that these can be viewed as sets. So if you see A and B non-negative, but A plus B is less than or equal to 2, let's just say I say for all A and B, E equals the set of, for all A and B, Sorry, I'm writing this backwards. A and B such that E. Okay? So if we say that E is the set such that is the set of all A's and B's such that E holds, and then we say B is all A and B such that, and I'll put a period to show that it's a problem, the answer B holds, and then I say C is the set of all A and B such that answer C holds. Well, then now we have a difference in sets. And now we have something that's clear, because one of the things my TA said was, well, if A or B was negative, then, well, this would be incorrect because it's not true for a negative number. Well, this doesn't imply anything about there being negative numbers, because there are no quantifiers here. Just like here, there's no statements about A and B being less than 2 or any other number. It just says that A and B are non-negative, which is a true formal evaluated statement. It doesn't provide all information about A and B, but who's to say that E provides all information about A and B? I mean, we're not even saying anywhere that A and B are integers or anything like that, and we would probably have to define integers if we really wanted to do that anyway. So, anyway, these are sets here, and what we really should do if we wanted to make B and C incorrect answers is to say that, well, B is this set. A and B are, this set exists, or this set exists, and holds, because then, let's see here. If we wanted to say the most restrictive set, because we could say that whatever we're looking for is possibly a subset of E. Maybe it is E. But if we were looking for a specific set, obviously these sets would be different, and only one of the sets would be correct if we are looking for a specific set. If we're looking for something that could be a superset or a subset, then they could overlap. So I think that's kind of the point. Or related to the point, I guess. But yeah, you could say such that, you know, A and B are natural numbers, and that's fine. Or you could just say that A and B are reals, and as long as that includes naturals or whatever the problem has to deal with, then it works. As soon as it doesn't include the types that you need, then of course it would be incorrect then, because you're putting a restriction that doesn't allow it to work. So this is kind of, in computer science, it's like polymorphism in generics. It's allowing this function, this addition, and this less than or equal to test or operation, whatever you want to call it, to not be restricted the way it's defined. It's kind of defined very generally. It kind of it's defined over things like maybe complexes or reals or something, and you can restrict it to just evaluate for natural numbers or to a small set, like maybe the set 1 through 5 or something, or an interval. So just because you don't explicitly say all the values that A and B can possibly be doesn't make this statement incorrect. And I don't know how many times I have to say that, but it's just a fact. It doesn't make it incorrect. Because that's not just simply not how expressions work. They don't necessarily always have to restrict. If they do, then that should be defined. That should be said, and that would be built in. But it doesn't mean that that statement is wrong. So anyway, let me know what you guys think about this. And it's more kind of this trying to prove someone wrong type topic, but it's kind of something for me to kind of get off my chest and kind of just share with the world, so that I don't have to think about it and internalize it so much, but I can just kind of show other people and see what they think, and hopefully keep a community around me who is interested in the kind of research and the things that I'm interested in, and will encourage me to kind of make progress in the areas that I'm trying to make progress, which of course relies heavily, especially the project that I'm working on now, relies heavily on logic, and on logic that most people, most even computer scientists, are not really used to thinking in, even me. But and I'm expecting it to be extremely useful. So this is definitely something that computer scientists and logicians and people will kind of understand, but trying to find the best way to communicate, the best way to, I guess, define multiple choice answers is kind of a good practice, and any comments on that are welcome. Happy to converse. We just try to keep everything nice, I suppose. And thanks for watching my videos. I really appreciate it, and I will talk to you guys later.